In this chapter, we will see how RPG programs communicate with one another by passing parameters. We will also see how control language commands can be executed from within an RPG program. And we will also see how data can be shared between programs through data areas. Let us begin with subprograms. A subprogram is a program that is called by another program within the same job. The ability to call one program from another allows us to develop applications that are made up of a number of small, standalone modules of code. The modular approach to programming has a number of advantages. Code that might be used very frequently by different applications can be put into a separate program and shared rather than having to repeat the code in each program. Code that is infrequently used could also be separated out into a subprogram, thereby reducing the size of the main program. Also, it is much easier to maintain programs that are smaller and less complex. Another advantage of using subprograms is that all the subprograms do not have to be written in the same language. Subprograms can be written in any of the high-level languages supported by AS400 as well as in control language. Any program can call any other program. This allows us to take advantage of the strengths of different programming languages by coding certain functions in a language that is more suited for the particular function. One important point to note here is that RPG programs are not recursive. RPG uses the call operation to pass control to a subprogram. The call operation passes control to the program named in factor 2. Factor 2 can contain either a literal specifying the program to be executed, or it could be a field, array element, or named constant that specifies the name of the program to be executed. Using a literal is the most optimal method as it reduces the overheads involved in security and existence checking. When program execution reaches a call statement, control passes to the called program. The called program executes until it reaches a return statement that causes the control to be passed back to the calling program. Control returns to the calling program at the statement immediately following the call statement. Let us see how values are passed between the programs. RPG uses the parameter operation to identify the fields whose values are to be shared between the programs. Each parameter statement in the calling program must have a corresponding entry in the called program. Each parameter statement requires an entry in the result field. This could be a field, data structure, or array that will be used to pass values to the calling program. It cannot be a literal, a label, a constant, or a table name. When parameters are passed from one program to another, what is actually passed is a reference to the memory location at which the parameters in the calling program are located. The corresponding parameter entries in the result field can have different names, but have to be of the same type and length since they refer to the same memory location. The parameter statement has to appear immediately following a call operation. It can also appear after a PLIST operation. A PLIST is used to identify a parameter list. Factor 1 has to contain the name of the parameter list. Once a parameter list has been defined, you can use it on the call command instead of listing each parameter individually. Let us look at an example. In the first example, we have a program, PRG1, that calls a program named PROG2. Immediately following the call operation, we use a sequence of parameters operations to identify each of the parameters that are to be passed to the called program. In the second example, we first define a parameter list consisting of 3 parameters: FLD1, FLD2, FLD3. On the call statement, we specify the name of the parameter list in the result field. When the call statement is executed, the fields on the parameter list will be passed to the called program. Let us now look at the called program. The called program receives the parameters passed to it through a series of PARM statements. As we mentioned before, the called program receives references to the memory locations of the fields and not the actual values. Here, the parameters are to be written within a parameter list. The parameter list has to be named entry in factor 1. A program can have many parameter lists, but only one entry PLIST. Also, remember that the variables used as parameters must be declared in their respective programs. Since RPG passes the addresses of the memory locations containing the field to the call program, any changes made by the call program will be reflected back in the calling program. For example, say in program PROG1, FLD1 has a value of 10 when the call statement is executed. The reference to the memory location of FLD1 is passed to PROG2 through the parameter FLDA. PROG2 changes the value of FLDA to 9999. When PROG2 completes execution, control passes back to PROG1. The value of the field FLD1 has also changed to 9999 since both FLD1 and FLDA refer to the same memory location. To avoid having the original fields modified by the called program, we can use factor 2. In factor 2, we can specify the name of the field we want to pass to the called program. In the result field, we specify a new field. Now, when the call statement is being executed, the system copies the value of the factor 2 field to the result field and passes the addresses of the result field to the called program. In this way, the called program cannot change the value contained in the original field. Similarly, in the called program, we can specify a local field in factor 1. After the call program receives control, the value in the result field is copied to the field in factor 1. As we just saw, when exiting from a program, the system copies the values from the factor 2 field into the result field for each PARM statement. When entering a program, the system copies the values from the result field into the factor 1 field for each parameter. Following these rules, when the call program completes and passes control back to the calling program, the contents of factor 2 of each parameter operation are copied to the result field. Similarly, when control returns to the calling program, the values of the result field are copied to the factor 1 field. One important point to note here is that when constructing parameter lists, all the fields to be passed in both directions must be included. Let us now take a look at the QCMDEXC program. Sometimes, from within an RPG program, you might require to run a RCL command. QCMDEXC is an IBM supplied program that allows you to run a single CL command. The QCMDEXC program expects two parameters. The first parameter should contain the command that is to be executed, and the second should contain the command length. The return operation is used to pass control back to a calling program. If the return is specified without setting on the last record indicator, the called program remains active. When the program is called subsequently, all the fields and indicators will have the same values that they had at the time the return operation was issued. Also, all the files that had been opened by the called program will still be open. If you set on the last record indicator before returning from the called program, all the system resources that had been tied up by the program will be released. The next time the program is called, the variables will get reinitialized and the files reopened as though for the first time. The last record indicator provides an implicit return. Control returns automatically to the calling program at the end of the fixed logic cycle. Hence, it is not necessary to include a return statement when the last record indicator has been set. The free operation can also be used in the calling program to deactivate a called program. The name of the program to be freed is to be entered in factor 2. It removes the program from the list of active programs, releases static storage used by variables, and some of the ODP information is also removed. However, files will remain open and data areas will remain locked. When the program is called again, first cycle processing will be required. The reclaim resources command can be used in an application to free the static storage occupied by the fields and to close any files left open by other programs in the application that are no longer active. The QCMDEXC program can be called in an RPG program to run the reclaim resources command. While parameters allowed us to share data between calling and called programs, data areas can be used to communicate between independent programs running in the same job or in different jobs. Let us now look at data areas and see how they can be used in RPG programs. A data area is an AS400 object that is used to hold data so that it can be shared among jobs on the system. It can hold only a single piece of data. In the case of character values, it could be logically split into multiple pieces of information. It is generally used to store small quantities of data that are used frequently by several programs or by the same program each time it is run, such as the next order number, customer number, or check number. It can also be used to store constants such as tax rates or to transfer the processing results of one program to another. It is much easier to retrieve information from the data area than to retrieve it from a database. There are different types of data areas. You have general data areas, local data areas, and group data areas. A general data area is created by the user through the create data area command. It can hold only a single piece of data that can be either character, numeric, or logical. In the case of character values, it could be logically split into multiple pieces of information. The user can delete general data areas when it is no longer required. The local data area is a special type of data area that is automatically created by the OS400 whenever a new job is started. It is used to pass information between the different programs running in the same job and is not visible to other jobs. The local data area has a fixed length of 1024 bytes and can only contain character data. It is deleted by the OS400 as soon as the job ends. A group data area cannot be accessed in RPG programs and is not discussed here. An RPG program can access both general data areas and the local data area. The DEFN operation is used to associate a data area with a field within the program. Factor 1 must contain NAMVAR to identify that the DEFN operation is being used to define a data area. You could use the same name for both the data area and the field used in the program, or have a different field name. To use the same name for both the data area and the field in the program, leave the factor 2 entry blank and code the data area name in the result field. To use separate names, code the data area name in factor 2 and the field name in the result field. The operations that can be used with data areas are in, out, and unlock. The in operation is used to retrieve the contents of the data area into the program. Factor 2 must contain the field or data area name that was specified in the result field of the DEFN operation. A value of *LOCK in factor 1 can be used to place an exclusive allow read lock on the data area. The lock remains until either an UNLCK operation is used or the program ends. The UNLCK operation makes the data area available to other programs but does not update the data area on the auxiliary storage. The name of the data area has to be coded in factor 2. The OUT operation can be used to update the data area. A data area can be updated only if it has been locked. A data area is automatically unlocked after an out operation. A value of *LOCK can be used in factor 1 to retain the lock after the updation is done. When accessing multiple data area from within a program, you can read and write all the data areas in a single operation by specifying *NAMVAR in factor 2 of the in and out operations. Let us now see how to access a local data area. There are certain restrictions when working with the local data area. The reserved word *LDA cannot be used on the in and out operations. Hence, it has to be always associated with a field on the DEFN operation. Once it has been defined, the local data area can be read from and written to using the in and out operations and specifying the name of the field within the program. Later on, we shall see how the data areas can also be accessed through the use of data structures. This brings us to the end of this chapter. Summary. In this chapter we saw how programs could communicate with each other. We studied the concept of subprograms and saw how parameters could be used to pass data between a calling program and a called program. We also looked at data areas and saw how data areas could be used to pass data between programs running in the same job or in different jobs.